Solution for question number 4. So basically question number 4 is from chapter 10. So the question is, a toy siren is approaching a wall of speed 2.5 meter per second. So we have a toy moving, okay, and this is the velocity of the toy. So in this case, we have the case of source moving or moving source. The siren produces a sound wave in the form of y is equal to 0.004 sine 0.5 pi times 2 to 0t minus 6.4 s. So the first question is calculate the speed and the frequency of the sound wave. So to solve number 1, okay, we have velocity of sound, v is equal to f lambda. So we need to find the frequency and also we need to find lambda to get v. So we need to find the frequency and lambda. So the frequency, we can have this from omega. So omega is equal to 2 pi f. Okay, so our omega is equal to 0.5 times 2200 equal to 2 pi f. So frequency is equal to 550 hertz. And then we want to find our lambda required from k. So knowing that the equation of k is 2 pi over lambda. Okay, so we have k is equal to 0.5 pi times 6.4 from the equation in the question equal to 2 pi over lambda. Okay, then you will get lambda is equal to 0.625 meter. Okay, then once you have got your lambda and your frequency, then okay, so we continue here. So you will have your v is equal to f lambda. So it is equal to 550 times 0.625, and your velocity of the sound is 343.75 meter per second. Okay, so that is the equation, the velocity for the sound wave. Okay, question number 2. Okay, calculate the frequency detected by the detector. So basically, if we read the question carefully, this question is about Doppler effect. So we can straight away recall our equation, our general equation for Doppler effect. So that is velocity of sound plus minus velocity of observer divided by velocity of sound plus minus velocity of source times the frequency of source. Okay, so we have to, so our specific equation for this question is to be depending on our case. So our case is a stationary observer. Okay, stationary observer, meaning that we know our VO is equal to 0. Okay, so basically you can cancel out this VO. Okay, and then we have approaching source. Okay, approaching. So because of the source is approaching, so we expect that our apparent frequency is higher. So the specific equation to be used to solve this question is F is equal to V over V of sound over V minus V of source times the frequency. So we substitute the values. So velocity is the velocity of sound, 343, the one that we have got from the first question, over 343 again, 0.75 minus, so we take this value of the velocity of source. Okay, so we have 2.5 times the frequency of sound. So the one that we find, again, the frequency that we find out from the first question, so times 550. Then the final answer is equal to 554 Hertz.